So the temperature in degrees Celsius of a surface of a metal plate is this. T function of x, y is equal to 20 minus x squared minus y squared, where x and y are measured in centimeters. In what direction from 2 to -3 does the temperature increase most rapidly? What is the rate of increase? So this question wants us to find the temperature increases, the rate of temperature increase in this surface metal here. So we already know, if you're given a question like this, you simply say it is the same as grad the function. And our function is x, y. So the function is, I think the function is here, as we can see it, xy. So we continue with the question, what is grad f? This grad here, it simply means the derivative of x and derivative of y. So let us find the derivative of x and derivative of y. So this one is equals to the same as derivative of x for this function here for function xy plus the derivative of y for the same function xy. So we know already our function txy, this function here, we can see this function here, this is the function of the function of txy here. So we go directly to find the derivative of tx and the derivative of ty. Derivative of x and derivative of y. It is simply just say derivative of x and derivative of y. So derivative of x is simply we can see here we have only one x, so derivative of this function is the same as 8x, negative x, 8x. So we write our negative 8x, and also derivative of this y here is the same as negative 2y. So we come and write it here again. The derivative of this function the same as negative 2y. So after we get this one, we need to add them. So come and say grad of this function of function x and y is the same as negative 8xi, the same as negative 8xi, and we write I like this. Let me write it well. So negative hi plus negative 2 or negative 2y j. We should write j here. So after that, we're going to replace we're going to substitute these points here, the points 2, negative 1. So we're going to say, let us go to the next page, another clean page. So this one is equal to negative 8 negative 8 xi, negative 8 xi, I think, so it will be negative 8 xi minus 2y 2y 2yj. But we know our points which we're supposed to substitute from the same as 2 and negative 3. So we come and replace them with here. We substitute them here. So we come and say 8 into brackets 2, and you should not forget it was negative 8. It was negative 8, then minus 2 negative 3. So here we had I, and here we have j. Once you do that, we're going to say our grad t to point to negative 3 is equal to negative 16i negative 16i minus, it is plus 6j. So after getting this, we need to answer the question. We need to look at the rate of increase, and the rate of increase is simply maximization. So if you are finding the rate of increase of something, according to the formula, let us go to the next page here so that I can write for you here. Because we already have our grad at point 2, negative 3. So we say the rate of increase is the maximum value of du. So it is the maximum value. We write it here. We need to find the maximum value, which is the same as du derivative of t xy. That is a simple mean du derivative xy, where we need to find, so the rate of change, the maximum value of du t function xy is the same as we find the norm. We need to find It is the same as the norm. So let us write it here very well. The same as the norm of this, and the norm of that the same as square root. We know our derivative of this is the same as negative 8. I multiply by that. So after we no, it is negative 16. I mean, it was negative 16 plus 6. So here we do 16 squared. 16 squared plus 6 squared. So this is simply, this is going to give you 17.09 degrees Celsius. So the change of the rate of increase is this one here. The rate of increase is that. Thank you.